Ever stop to wonder how something like Netflix or Amazon can possibly handle millions of people all at once? Well, today, we're going to pull back the curtain on system design. This is the blueprint, the architecture that powers our entire digital world.
I mean, seriously, how does a service like Twitter or Instagram actually work? We're not talking about just a handful of users here. We're talking about this insane, mind-boggling scale of data, and it's all happening in real time. You know, the simple answer is you can't just run it on one giant, super powerful computer. It just won't work. A single machine, no matter how beefy you make it, it's just never going to handle that kind of load. The real problem here is scale.
So to solve this, engineers build what they call distributed systems. And really, all that means is instead of one machine doing all the work, you have a whole team of them, all spread out but communicating and working together. And this one simple idea, it's the absolute foundation of all modern system design.
Okay, so how do you actually build one of these things? Well, it turns out that every massive system, I'm talking Netflix, Google, you name it, is built on just a few core unbreakable rules. You can really think of them like the laws of physics for the digital world.
First up, the system absolutely has to be online and ready to respond, always. This is what we call availability. It means that even if parts of the system fail, and trust me, they will, the service just keeps on chugging along. Second, it's got to be able to grow, right? As more and more users sign up, as more data pours in, the system needs to handle that bigger workload without even breaking a sweat. That, my friends, is scalability.
So how do we get that growth? Well, there are really two main ways you can do it. You can scale vertically, which is just making a single machine more and more powerful. Or you can scale horizontally, which is adding more machines to the team. And for these massive services we're talking about, horizontal scaling is almost always the answer.
And third, the data has to be correct. It has to be trustworthy. Think about it. When you update your profile picture, you expect everyone, everywhere, to see the new one, not the old one, right? That's consistency. It's all about making sure every part of the system has the same correct data.
Okay, so we've got our rules: availability, scalability, and consistency. But how do we actually build a system that follows them? Well, designers have this kind of digital toolbox, a set of essential building blocks that they use to make it all happen.
So let's start with a really common problem. Let's say your service gets featured on some big website, it goes viral, and bam, a flood of users just overwhelms your one server. It crashes. Now what do you do?
The solution is our very first tool, the load balancer. I love this one. It's basically a traffic cop for the internet. It stands out in front of all your servers and just intelligently directs all the incoming requests so that no single machine gets overloaded. Pretty clever, huh?
All right, so you're handling the traffic now. Great. But with millions of users, you've got a brand new problem. This gigantic, ever-growing pile of data. All those tweets, all those photos, all those user profiles, they have to be stored somewhere safe and, organized.
And that is the job of a database. You can think of it like a massive, permanent digital library for all your data. And there are different kinds, of course. You've got your superstructured relational databases, kind of like a spreadsheet on steroids, and then you have more flexible NoSQL databases. Each one is good for different kinds of data.
Okay, so your database is perfect for permanent storage, but it can be a little slow. So what happens when thousands of people are all trying to look at the same viral photo at the same time? Going all the way to that database library to fetch it over and over again is just not efficient.
This is where our next tool comes in, the cache. A cache is just a layer of super fast, short-term memory. It keeps a copy of the most popular, most frequently accessed data ready to go. So instead of going all the way to the library every single time, you just grab it from this little ready access shelf right next to you. It's instant.
Now, as your system gets bigger and bigger, it's not just one single program anymore. It's a collection of separate services, right? You might have one for user profiles, another one for photos, another for notifications. So how do they all talk to each other without having to wait around for a response? It could really slow things down.
The answer is something called a message queue, and it acts like an internal postal service for your system. One service can just drop off a message like, hey, a new photo was uploaded, and the other services can pick it up whenever they're ready. This is huge because it decouples all the components, making the whole system way more flexible and way more resilient.
All right, we've got the rules, we've got the toolbox. Now let's put it all to work. We're going to design a real-world service, a URL shortener, like Bitly. It seems super simple on the surface, but it actually uses all the principles we've just been talking about.
Okay, so here's the blueprint in action. Step 1. A user's request to shorten a URL hits our load balancer. That gives us high availability. Step 2, the load balancer sends it to one of our many servers, which generates a unique short ID. Step 3, that short ID and the original long URL get stored together in our scalable database. And finally, step 4, the new short URL is sent right back to the user. Simple, right? And later, when people click that link, we could use a caching to serve up the redirect instantly, without even having to bother the database.
So here's the really crucial point I want you to take away. System design isn't about finding one single perfect answer. It's really more of an art. It's the art of making smart trade-offs and choosing just the right combination of tools for whatever specific challenge you're facing.
I mean, just take choosing a database. If you're building a banking app, you need absolute, rock-solid consistency for your transactions, so relational DB is the only way to go. But if you're doing something like web caching, where speed is king and you can afford to lose a little data now and then, a flexible key-value store is a much, much better trade-off.
Ultimately, that's what it's all about, balancing these competing needs. You're always trying to build a system that is available and scalable and consistent and maintainable. It's this giant puzzle where you're constantly weighing the pros and cons of every single piece you put in place.
Look, we've only just scratched the surface today, but you now have the fundamental principles and the essential digital toolbox. So the final question I have for you isn't just what could you build, it's what problem are you going to solve first?